So these are the vertices. So when this order is given, so from there we have to check whether from this order we can get any depth-first spanning tree. So for that we have to construct a spanning tree according to the depth-first search traversal. So how to construct that spanning tree? First we have to just draw all the vertices without connection. So I am drawing the vertices here: A, B, C, D, E, F, and G. So the starting vertex is A. A is the starting vertex. So the next vertex that we can count that after A that comes is B. So I have to check whether there is any edge between A to B from the original source graph. This is the source graph. Okay. So there is an edge between A to B. So we draw this edge. So in depth-first search, what happens that when a tree will be constructed, we have to go, taking a particular branch, we have to go to the utmost depth. Then when all the depth up to the last depth, when it is covered, then we backtrack to previous level, and from there on, we will try to searching for another path and will go to the deepest vertex for that particular path. And when all the vertices for this particular branch has been covered, then we backtrack to previous level and again try to find out if there is any edge which is not traversed before. Then we have to cover all the vertices along to that path. So here from A to B there is a path. It is clear from the source. Now the next vertex to be traversed will be C. Now the next vertex which will be traversed after B, so that will be C. So I have to check whether from B there is any path to C or not. Here from the graph we find there is a path from B to C. So this path is connected. Now after C, the next vertex that is to be traversed is G. So I have to find out whether from C there is any path to G. From this given source graph we find that from C there is no path. So what we will do? We will backtrack to previous vertex of C. That means now we have to check B. Now from B, is there any path to go to D? See, from B to D there is no path. So we put a cross marks and we backtrack to previous vertex, which is A. And now we have to check whether from A there is any path to D. Yes, there is a path, so we connect to this path and this is checked. So there is a path from A to B. Next we have D has been traversed, and we have to check whether any path from D to E, because D is now the current vertex position. So from D, is there any path to E? Yes, there is a path. So we connect this. Okay. Then the next vertex is F. The current vertex is E. So from E, is there any path to F? Yes, there is a path. So we connect this. The next vertex to be traversed is G. Current vertex is F. So from F, is there any path to G? Yes, there is a path. So we connect to this G. So this becomes the depth-first search spanning tree for DFS order given. So if the DFS order is given, and from that, if we build a DFS spanning tree, then we can find out. So this is a DFS spanning tree, which is actually found out from this traversal order, and this is the DFS spanning tree from this particular graph. Now, if we check another traversing order, so for that also we can similar way we can find the spanning tree. For example, we consider a different or different search order, traversal order. Suppose A, D,